Hello everybody, my name is Alberto Marquez. In this video we will talk about data frames in R. As you remember, frames comes as the next level of sophistication in the use of information in R. Matrices are limited to have only the same data type. R frames are allow the user to have different type of information, text, and say for instance one column with text, one column with numbers, or maybe another column with. So we're going to work on that now. Data frames are very useful because you can combine these different type of information, and they are very they are the essentially where you're going to do most of your work when you work with R. They have the benefit of being able to name the rows and the columns, as you can see, and there's a lot of functions that you can use to exploit the information. You can create a data frame by the statement data.frame and then use vectors to populate that frame. As you can see, the populating process works by column. You create first the vectors, and then each one of the vectors takes the position of one of the columns. All right, so let's work a little bit with this tool. Here we are in R, and I have already loaded a couple of data frames by using the CSV file. Let me demonstrate that by just typing read. Make this a little larger maybe. I can do if I do my vector, and we're going not my vector, my data frame, and we're going to use read CSV, and I already have a CSV file containing information that I will be using, and I changed the name to something very convenient, which is just file.csv in my working directory. Alright, here we are in RStudio, and I'm going to start with a very simple command for me to populate a data frame, and we're going to do my data frame is going to be read come by reading a CSV file. So all I do is read CSV, and that's part of the tools that you already have, and then we need to specify the file that you want. So it's file equals and the name of the file and the location. If I want my data is in R data, and I can select that as the location that I wanted to read. So all I need to do is add the files. In my case, I have file1 CSV, and now my data frame has that, and it has 922 rows. Okay, so the first row is named X. What the CSV file contains, in the first row contains the title of the column. So that's something that you need to prepare. Make sure that you don't have any other information in the CSV file. Sometimes CSV files come noisy, and you need to clean a little bit those extra noises, and before you enter those into your R program, into your data frame, because otherwise it's going to be hard for you to clean it. So if in as much as possible, if you can have a clean data set from the beginning, a clean CSV file, that would work better. So here I have a column that is named X, and that works very well. And now I'm going to do a few operations with the second summary of my data frame, and that will give me the minimum, the maximum, the first, the median, and the third quartile, and the mean. So this is already interesting and useful. I can specify other things like for instance standard deviation. I can compute the standard deviation, and what happens if I do the standard deviation of my data frame. Okay, if I do that, I am going to get an error. So what I need to do is I need to specify the standard deviation I'm looking for is standard deviation of the first column, and in order to do that I can say, well, it's not the rows, it doesn't matter, but I want the first column, and then that computes the standard deviation of the first column, and I can compute just as equally the median, the mean again, and the name is my data frame, and I cannot, if I don't know the location, which columns I'm looking for, but I know the name of the column, I can use the name of the column as well. So that gives me the mean, and of course I can do the standard deviation. Very good. So there are other things you can do with the data in a data frame. You can write the data frame into a CSV file as well. All you have to do is type write.csv and then my data frame, which is what you want, and then you specify the file path, file equals, and then you would have to type in what do you want exactly to call that CSV file. All right, so that works well. Now, what happens when I try to do kurtosis? Kurtosis is a measure of the thickness of the tails in a distribution. So if I do kurtosis of my data frame, etc., what would happen? It's saying that it doesn't find the function. However, this is a statistical package, so I would expect to be able to see a way to do kurtosis. Well, if you look into the internet examples, you will find that you need to add one of the packages. Packages are libraries that help you have more sophisticated functionalities that include, for instance, the preparation of graphics and other similar things. So in this particular case, the one that we need for, and this is something you can just Google, if you do kurtosis in R, you will find in the examples that you need to have this library E1071. If I select it, it already selected it for me, and now maybe I can compute the kurtosis. There you go. And the only difference is that it uploaded the library for me. How do I do that? Well, I have to have the package. Sometimes you have to install the package, and if you want to do that, you just go to install, and here you have to enter the name of the package that you want to install. Here is just using it, and it may be that in your case you need to install it, but RStudio prepared to help you do that. So we can compute the kurtosis, and we can compute the skewness. There you go. Skewness is prompting me my data frame, the kurtosis, the skewness on column X. There you go. So it is very, very useful to know all of this, to compute your statistics, and it's not really complicated at all. You can also find particular locations in your data. For instance, you may want to know the content of my data frame in row, say row 76, and column X. In this case we only have one column, but it may be that you have several columns, and that's the value that you have in this particular case in row 76, and that column 1023. So all the other operations work as well. You can define columns and names for columns and names for rows, and count how many rows and how many columns you have. But essentially these would allow you to manipulate your data in a very efficient way, especially when you have access to the packages that make R very, very powerful. All right, well, let's cut this video here, and this should be able to help you work through most of your assignments. Goodbye.